So flange here, we're starting off with points and lines. And we look at the idea of a point. What is a point? In geometry, it was actually something undefined. You drew one, you made a little point, and actually as soon as you start making it big, it's got more dimensions than it's supposed to have. It's supposed to have no dimensions, no width, no height, no length. But that was a point in geometry, and you can make a bunch of points like that. In algebra, we got more specific with a coordinate system, where when you put your dot down, your point, you gave it coordinates A, B. Or this one looks like it's about 2, -3. Okay, so that's one of the differences between algebra and geometry. We can actually define points in terms of coordinates in algebra. In geometry, we usually just label them like point A, point B, and point C. Okay, now one thing about points in algebra is we have our coordinates in quadrants. Quadrants 1, 2, 3, and 4 labeled with Roman numerals counterclockwise from the upper right, like that. Okay, so where is the point -3, 2? In quadrant 2. You back up 3 on the x-axis, go up 2 on the y, and there's your point at -3, 2. Okay. So look at the next idea here. What is a line? Geometry, you drew those all the time. Usually, in geometry, you'd have to have 2 points. We can get really fancy with our lines here. Let's make a really nice line. Oh, some would call that a ray. That's okay. Pretty straight. In algebra, when we think of a line, we think of the equation for the line. Like 3x plus 2y equals 6. Which do you think of as a line more? Geometric definition or the algebraic definition? Well, turns out they both can be used to define a line. In geometry, you'd almost say 2 points on the line, and you'd use that little symbol, AB, with a line symbol over it. Say line AB. Here in algebra, you can represent a line with an equation, 3x plus 2y equals 6. And oddly enough, though, to graph it, we always talk about you having 2 points. So, easiest way in this case is to just do an xy chart. Find the intercepts. Put 0 in for x, and that leaves you 3 for y. Put 0 in for y, and you put your hands over this one. Think of that as gone here. 3x equals 6, so x equals 2. So 0, 3, and 2, 0. And you've got your line. Okay? That's the line. Now, be careful, and we're going to get a lot more into this tomorrow. The idea of lines don't always have to come to this form. Sometimes they're like in y equals mx plus b form. We'll talk about the different forms tomorrow. Y equals 2x plus 1, some advantages of that. You know the point 1, you know the slope is over 1 up 2, and we're about to talk about slope in our next section. Yes, I also have to watch out for lines that can sometimes have a slope. X equals 3 as an undefined slope, because it's a vertical line. Y equals 2 as a 0 slope, because it's a horizontal line. And oddly enough, when you think about the point 3, 2, it's the intersection of those two lines. X equals 3 and y equals 2. 3, 2. That's actually what we're implying when we label a point like that. Okay, next concept. Intersections of lines. The geometry versus algebra idea. Well, in geometry, you can intersect 2 lines. And I don't know why. Let's go with this here. There's a line, and there's a line. And clearly they cross at that point right there. The intersection of 2 lines is a point. Or we could have parallel lines. Oh my gosh. Think about parallel lines. Is that they don't cross, so you don't get an intersection. Well, what happens algebraically with this? Well, you can have a couple equations of lines, and you've had a lot of practice on solving systems, like 3x minus 4y equals, oh, can I say 2? And 5x plus y equals 11. Okay, 3x minus 4y equals 2. 5x plus y equals 11. Can you think of why I know these have got to cross? Thinking about it? Well, that's right. They have to have different slopes. And next we're going to talk about slope in our next section, but you'll see that this has a slope of 3/4 and this has a slope of -5. And if they have different slopes, then they can't be parallel, and we won't get this case over here where they don't cross. So let's go on and see if we can't solve this system. 3x minus 4 equals 2, 5x plus y equals 11. There's a couple of approaches on solving the intersection of two lines. And one way is to see if we can't do a good sketch and luck out. Could we possibly figure out where these two cross with some really good graph paper? Well, the intersections of the xy coordinates aren't too nice. I mean, they're really not in the nice graphing form. This one isn't too bad because we could change the y equals -5x plus 11. So we go way up here to 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Way up here, and then a slope of, it'll be -5, so it'll come swooping down like that. This one, 3x minus 4y equals 2, you can try and think of some points that might work on it, but if you put in 0, you get -1/2. So it's down here. If you put in 0 for, I just put in 0 for x, and I got -1/2 for y. If I put 0 in for y, I get 2/3 for x. This is sometimes the problem. See, those points are so close together, it's kind of hard to see what they might cross. But are you going to take a guess at it? I'm guessing 2, 1. And oh my gosh, 2, 1 works in both equations. Whew. Well, you know, this relies on someone giving you nice answers and then you getting lucky. And maybe if you had graph paper out, and later on I'll show you how on these pads we can whip up the graph paper. But I think you remember the system trick here. We take this first equation and let's multiply it by 4. I'm sorry, the second equation multiplied by 4, so it actually makes 20x plus 4y equals 44. And now you can take those two equations, this equation and this equation, and when you add them up, you're going to get 23x. The -4y and 4y cancel out, equals 46. And look at that, x equals 2. And then you got to sub back into either of the original equations to come up with what y is. 5 times 2 plus y equals 11, so y equals 1. So there's our algebraic approach to coming up with the answer. It takes a little longer, but of course it's more accurate. And here we kind of lucked out here, but we can visually get an idea of where the intersection is by sketching the two lines. Okay. Next concept. Just some formulas I'm sure you've got memorized already. Given 2 points, and let's call them x1 comma y1. We like to use subscripts. x2 comma y2. And one of the reasons for that is now we can easily extend it to 3 dimensions, which we'll be doing next semester. We'll be looking at these formulas in 3 dimensions. But right now let's focus on 2 dimensions. What is the distance between them? Let me try and jog your memory. Maybe you've got the formula memorized. It's nice to know where the formulas come from, though, people. Here are your 2 points, x1, y1, x2, y2. And basically, we're making a right triangle out of this. And if this is x1 and this is x2, the coordinates on the x-axis, x1 minus x2 represents the gap between them. Technically, it's the absolute value, just like y1 and y2, you're going to take the absolute value of y1 minus y2. And these two sides form the sides of a right triangle. And remember from the Pythagorean theorem, c squared equals a squared plus b squared. minus y2 squared, absolute value. But because we're squaring, the absolute values become redundant. So the distance is the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay? That's the distance formula. Midpoint formula is a lot easier, just the average. Average of the coordinates. Average of the coordinates. So the midpoint is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. If someone wants to come up with a nice proof for this using a combination of geometry and algebra, be my guest. You can submit it and we'll add it to the notes. Okay, now we're going to do some more examples of this in class time. I'm going to save some space for that. 1, 2.